All right, so talking about an isosceles triangle, and remember that in an isosceles triangle, you have two sides that are the same length. Okay? Now, the legs of an isosceles triangle are these two sides that are the same length. And it doesn't matter how the triangle's rotated or flipped or whatever, the legs are the congruent sides. Okay, the other side is called a base. And again, base, we usually think of the bottom of a triangle as the base. But because we're talking about an isosceles, it doesn't matter which way the triangle is turned. The non-congruent side is the base. Okay. Then you have the vertex angle. This is the angle located between the two legs. The other two angles are our base angles. Okay, and it's very important to know which are which because there are theorems that talk about these specifically. If two sides of a triangle are congruent, here and here, then the angles opposite those sides are congruent. So if I go across this side, that's the angle opposite. Here, this is the angle opposite. And so you end up with congruent base angles. So the theorem is if two sides of a triangle are congruent, then the angles opposite those sides are congruent. But really, all you need to memorize is that the base angles in an isosceles triangle are congruent. They're equal to each other. Okay. Now the converse goes the other direction. Okay, so the converse goes the other direction. The converse flips things around. So it's if two angles in a triangle are congruent, so we start with the angles, then the sides opposite those angles are congruent. So the theorem starts us with the sides being congruent and then gets us the angles. The converse of the theorem starts with the angles congruent and gets us the sides. But it's still the same thing. If you have an isosceles triangle, your two legs are congruent and your two base angles are congruent. And my first question says if AC, that's this whole side here, AC, is congruent to AD, I need to name two congruent angles. Now, I can't just say angle C. Do you know why I can't just say angle C? Because there's two angles there. And I have to know which one I'm talking about. So I have to say A, C, D. And then angle D, I can just say angle D because there's only one angle there. So across from side AC is angle D. Across from side AD is angle ACD. So those two are congruent. Questions on that?
So anything that's like anything that ends with D is just regular D?
It can be just D, yeah. Because see how angle D doesn't have any other, it's just one angle. But angle C has two lines, angle B has two angles, and E actually has three. Yeah, this is in the, sorry, let's look at that. So we've got now BE is congruent to BC. So we're talking about this triangle, the little triangle in the center. Across from BE is this angle. Across from BC is this angle. Now both of these I'm going to have to name with three letters. Or you can go through and number them if you want. But BEC and then BCE with the letter of the angle always in the center. This could be ECB or BCE as long as C is in the center. That green's not really showing up, is it? Is that better? Okay. All right, we're going to go backwards now. We got EBA. So EBA is this angle. And then we have EAB is this angle. We have the congruent angles, so we want to talk about the congruent sides. Which sides are congruent? You go across from the angles. So we're looking for BE and AE. Any questions on that one?
Wait, but those segments,
Hmm?
are they actually congruent?
If these two angles are actually congruent, then these two sides are actually congruent. The pictures may not be drawn to scale. Okay? Yeah, because you go across, because the theory is that the angles, if the angles are congruent, or sorry, the theory starts with if the sides are congruent, then the angles across from the sides are congruent, and then it goes the other direction. If the angles are congruent, then the side across from the angles are congruent. So even though the picture may not be drawn to where the angles and the sides are actually congruent, the theory tells us if these two angles are congruent, then these two sides are congruent. And we trust the theory because the pictures are not always good. Okay, last one, we have angle CED. So CED, that's this angle, is congruent to CDE, that's this angle. So we go across and we get EC, and then we go across and we get CD. Yeah, you can do CE. Or you can say DC. With a segment, the order doesn't matter. Rays, the order matters because the first letter has to be the endpoint of the ray. Angles, the letters matter because the center letter has to be the vertex of the angle. But lines and line segments don't matter because it doesn't matter if you're going this direction along a line or the other direction, that's okay. So when it comes to line and line segments, you can name them in either order. If it's a ray or an angle, you need to be careful with the order. And if you're talking about congruent triangles, the order of the letters needs to match up to the congruent parts have to match up to each other. But if you're not talking about congruent triangles and you're just randomly naming a triangle out of thin air or something, it doesn't matter what order the letters go in. Is a triangle is equilateral if and only if it is equiangular. You can't be equilateral and then have different angles, and you can't have equal angles and then have different length sides. And it follows from that isosceles triangle theorem because if these two sides are the same length, then these two angles are the same. Well, if this is an equilateral triangle, if these two sides are the same length, then these two angles are the same. And if these two sides are the same length, then these two angles are the same. So it forces every side and every angle will be the same. And all of the angles are 60 degrees in an equilateral triangle. Because they're all the same, and there's three of them, so you take 180, you divide it by 3, it's 60. It can't be anything else. Okay. Every angle in an equilateral triangle measures 60 degrees, so this angle is 60 degrees, and this angle is 60 degrees, and that angle is 60 degrees, and all the sides match. Knowns and unknowns. Okay, so I have two sides that are the same length here. I'm being asked to find the measure of angle A, B, C. So that's this one right here. If these two sides are the same length, these two angles are the same. So if this one is 60, that one's also 60. Yes? Okay. Here I'm being asked to find angle EDF, so I'm being asked to find this angle right here. Well, these two sides are the same, which means that these two angles are the same. So I'm going to have two of these. Plus that one I know is going to equal 180. Right? So all three angles. And then angle D is equal to angle F. So I've got two of those. So if I take 180 and I subtract 40, I have 140 left to two angles. So I divide that by 2, and I get 70. So these are 70 each. Algebra. Call the unknown angles x. You have two of them. And together with that angle you know, you get 180 degrees. So you solve the equation. And you get the same exact answer in a nice algebraic way. So you have the not algebra or the algebra. Pick one. Okay, so these angles are the same here and here. And that tells me that these sides are the same. So I set them equal to each other. Okay. Subtract 3x from both sides, or subtract 2x from both sides. It doesn't matter. Subtract 4 from each side, or add 10 if you did the minus 2x thing. If negative x is equal to negative 14, that means positive x is equal to positive 14. Okay, found x. There it is. Questions on that one? No, well, maybe, but even if you did, if they said then find one of the sides, or you plug in 14, you'd have 2 times 14, I'm in my way, plus 4, so you'd have 28 plus 4, so both sides would be 32. Yeah. Now, on this one, we're going to have to do a little bit more thinking. These sides are the same, which means that these angles are the same. Only one of them's labeled, but if this one's 2x plus 3, this one is also 2x plus 3. Okay? They're the same. This is 90. So you can either do 2 of these plus 90 equals 180, or you can say 2 of those equals 90. It's going to be the same thing. But if you recognize that that's 90, that means there's only 90 left, then you don't have to go further. Now, you could distribute that too. Or you can realize that if 2 of them equals 90, that means one of them has to equal 45. Does that make sense? So I divided by 2 to start with, rather than multiplying it in to just divide it back out again. Does that make sense? Or you can multiply it in Let's solve it this way. Here I'll divide by 2. Here I'll divide by 4. Doesn't matter which way I go, I'm going to get the same result. So set it equal to 180 or set it equal to 90. 2 of them equals 90, so that means 1 equals 45, or distribute in the 2. So there's more than one way to get to this thing.